Good evening, everybody. Welcome to the TechX MeetUp, together with Magic Sandbox. Special thanks to Miklov, Johan, and Jort. Little agenda, we already opened with pizzas and everything. We have 2 sessions with a little break at 7:30, and at I think 2:30 to 45, we have some drinks afterwards. Coming event, 3rd of February, we have Venka Subramanian coming here. Sign up if you want. It's already quite full, there's already a waiting list, but you never know. We're always hiring. If you are interested, come to me in the break or after the breaks.
I guess we can start then. Hi, I'm Mislav. I'm the CTO and founder of MSB, of Magic Sandbox. We are an online Kubernetes training platform. Currently, we're focusing on Kubernetes, but hopefully in the future we will have a lot more technologies out there being taught the way that we think technologies should be taught, and I hope you'll see later what we mean by that. Our mission is to enable software engineers at any company to reach their full potential. I've had a lot of jobs before, and I've seen how hard it is to learn and how hard it is to get the whole teams to learn things. And our principle behind MSB is that the infrastructure is so cheap now that we can just give people servers to train on, and the browsers are powerful enough that we can create these guided experiences and teach technology in a much better way. This is a short kind of cut down version of the intro to Kubernetes workshop that we are doing. We are usually doing a whole day deep dive events where people work on their own clusters, and we really try to teach Kubernetes by making you actually deploy applications and doing actual things on the platform. Maybe before we start, like a few points, can you raise your hand if you have experience with Kubernetes? Okay. Does any of you consider yourselves advanced Kubernetes? Okay. Okay, then this is good. I'm just asking these questions to gauge how deep I'm jumping into certain topics, and I think this is a good collection of people here. One more thing that I would like to say is I tend to speak very fast, especially if I get into this, so please just tell me if something is wrong. Also, if there's any kind of questions there, this is not that big of a group that we can't pause anything, and if you don't understand something, if I'm speaking too fast, there's probably somebody else that's not understanding what I'm saying, and it's my fault, so please just interrupt me, let me know if anything is happening. So as I said, we are a Kubernetes training platform. The whole tech stack is built for the purpose of teaching Kubernetes. We're not a video platform that has a lot of other technologies. The content is developed by Nigel Poulton, author of the Kubernetes book. We managed to get him to work with us. He's very excited. And it started out of frustration with the current state of learning, where your CTO or somebody just sends out an email, we're going to Kubernetes, and then you're done. I just put this in. I think this is a good example of the current state of learning. You have a hello world stateless app, and suddenly, go step 2, go build a whole production app. We are trying to fix this problem. The agenda of our workshop today is split in 2 parts. One is this kind of intro to Kubernetes, where I'm going to try to build Kubernetes in your mind from the mind up and show you that it's a fairly simple thing once you wrap your mind around it. And then comes the fun part, I hope, where you can take out your laptops and each one of you will get your own cluster, and then we can break stuff and see what happens. So I'm just gonna take some water before I start. Intro to Kubernetes. I found that this way of presenting it is pretty okay, so I hope you will be able to follow along. But as I said, we'll try to build Kubernetes from the ground up and show you how it actually makes sense, how decisions are made in the architecture of Kubernetes. So let's start with a scenario where we have three machines running, and we would like to deploy software on it, right? So we have 3 machines running. Each of them has a Docker daemon and how to do it. You can manually use your Docker CLI, connect to it, and tell them to run a certain image. It's okay, software is running. It's technically in a state we want it to be, but it's far from production level system, right? It's a manual process, there's no healing, IPs are hard-coded, sensitive to hardware failure. If one of the machines goes down, you're in a bad place. So maybe let's try to make it a bit more resilient, a bit more smart. So let's say if we added these three exec, let's call them for now, processes running on each machine, and each one of them is reading from a config what it should be running. So suddenly it's a bit better system, let's say. If let's say Docker image goes down, Docker container goes down, let's say this exec process would start it up. It's a bit more resilient, but also not a very good situation because if a node goes down, the whole config is hard-coded and there is nothing to respond to the current, to the changing of the situations there. So let's add a few more things to our setup. So now we have standard 3 machines running, having Docker daemons running. This exec thing is still running from a config, reading what should be done. We've added a REST server in front of our config because everything's better with a REST server. And we have something that we will call a control loop for now on. What this control loop will do is our config has also changed in a way that we do not specify on which machines we want stuff to run. We just say we want Docker latest, Nginx latest, Postgres latest, or Redis, or whatever we want to run. And then let's see what our control loop in this situation would do. So the control loop is constantly looking at the current state and the desired state and trying to remedy this situation. So let's say the desired state was Docker latest, Nginx latest, Postgres latest. The current state was empty, and suddenly the control loop modified the config to say this one runs on node 1, this one runs on node 2, this one runs on node 3. Suddenly the exec processes receive this new information, what should be the current state, and they run it, right? So it's a bit more resilient system in our case. And let's separate one more thing out of this whole architecture, where the control loop, something we will call an assigner, is separated from this loop. And the purpose of this process is to look at the processes that do not have a node assigned on it, that are intended to be run, and it will look at the available nodes and assign it to a node. So this system, let's see how this system reacts. If there's any questions, please let me know. So current state, so we say our desired state is we want to run Docker, Nginx, and Postgres. Current state is empty. We have a control loop that realizes that these things are not set to be run. It will schedule it to be run, and the assigner will see that it's unassigned, and it will assign it to node 1, 2, and 3, and suddenly these exec processes have all the information they need, and the processes are active. So this kind of system is much more resilient to changes than what we had before. So let's maybe go through a few scenarios. Let's say if your process goes down, something is happening. You can see that the current state is missing something that is intended in the desired state. The control loop will see the difference between the current state and the desired state. It will say, I will schedule it, you need to run it. The assigner will also see that it's unassigned, assign it to an available node, node 3, and the process will be running. Another, let's say, failure scenario that we can explore is what if a whole node goes down? So suddenly, again, the current state is not matching the desired state. The control loop will again schedule it for execution. It is unassigned. The assigner looks, okay, I have only 2 nodes running. Assign it to node 2 in this case because there is no node 3 anymore, and the process is running there. So I hope you see the advantages of a system like this, because we are not, there is no iterative approach to anything, there is no hard coding of anything, there is just this organic approach to constantly checking between the desired state and the current state and doing certain actions to remedy the situation and adapt to what should be happening. So we've been talking in abstract terms, something like assigner and control loop and exec. We have now kind of built out actually what Kubernetes is itself. So this part here is the Kubernetes Master node, and this part here are the Kubernetes worker nodes. So a good way to think about Kubernetes is it's just a set of processes that's running on each of your machines in your Kubernetes cluster. What a Kubernetes cluster is a combination of a master node and at least one worker node. So let's go through the master node. So the key parts of the master node are the Kube API server, the REST server we've been talking about. It does more than just serve whatever is the current configuration. It also deals with authentication and a lot more things. So every time you are running a command or trying to interact with a Kubernetes cluster, you will be talking through the API server. The config is actually usually in case of etcd, in case of Kubernetes and etcd cluster. In a lot of these distributed systems, there's always a bit of a lie. It's not always, there's usually a single point of failure. In case of Kubernetes, it is the etcd and the API server. If these things go down, you lose everything that Kubernetes usually does all the magic for you. Your clusters will continue working, it's just there is no more self-healing and things like that. So how you run etcd is usually you run a 3-node cluster. There needs to be an odd number of these servers because they are using some algorithms to figure out what is the exact state. So usually 1 or 2 can go down and you can find the Kubernetes cluster will continue working. This is an important thing to realize because everything is happening through this API server and config. So usually, if you think of a command that how a Kubernetes schedules something to be deployed, it will not tell some process, okay, you have to run this. They will only put the configuration in a state that should happen, and then there's a lot of processes around it organically, constantly checking what's happening and trying to put it into a desired state. So let's go, Kube API server. It is a REST server, basically, that deals with authentication and a lot of other kind of stuff that needs to be in a production system. But basically what it is a point through which all the Kubernetes processes communicate through. The Kube scheduler is a very important part of the Kubernetes system. What it does literally is looks at work units that are assigned to be run, sees if they do not have a node assigned to be run on, and assigns them a node. So it's a very simple concept, but it has a lot of advanced mechanisms inside of it. So what it allows you is you can tell Kubernetes never run 2 database instances on 1 machine, because if this machine goes down, you lose 2 instances. Other things that you can do is say, I'm running TensorFlow application and I need the machine that's running it to have a proper GPU setup. So what the Kube scheduler does is allows you to create these hierarchies of how your services should be deployed on the system, and it does kind of automatically that for you. Oh, sorry. The Kube controller manager. It is a very important concept in Kubernetes. So it literally embeds a lot of the core control loops that are shipping with Kubernetes. And when we say control loops, we literally mean control loops as people who are building robots think of it. So it's all built in a way that constantly the current state and the desired state is being checked and trying to rectify any difference between them. So what it does is ships a lot of these control loops or these Kubernetes primitives that do a lot of this magic for you. So we will go in exercises through a few of them, But let's say a deployment object, a deployment control loop in Kubernetes, what it basically does is ensure that you have n instances of your software running. So if you tell deployment, I need 5 Redis servers, if one goes down, this control loop will constantly check if there's 5 Redis servers running and schedule a new one if it's not there. There are more advanced controllers there, but this is always the mindset that you have to have. Once you're more into Kubernetes and once you start using it in production, I've seen what's happening in my company. We rarely talk about machines anymore and pure sockets and things like that. We talk in terms of these Kubernetes abstractions. And this is, I think, a good way to approach it. About the worker nodes, they're also just a set of processes running on a machine. Basically, it is a kubelet, which is this process that basically just receives a list of these work units called pods. We'll talk later, but you can think of them as containers running and constantly ensures that it is running the containers that it should run. A kubelet also connects and validates itself to the kube API server. So in a process of setting up a cluster, you literally need to run these few processes and point them to a Kubernetes master, and things will work as magic. The kube proxy is something that we haven't talked about here. We won't talk about it much. What it does is, let's say, type of a controller, maybe not, but what it ensures is that networking is running smoothly on your cluster. So you will see that Kubernetes doesn't deal with sockets or things like that directly. It deals with these abstractions called services, and this is what does the magic to ensure it's all running. So usually, a good way, I always get questions, where exactly is the service, how exactly is it working? It's a very good question, we should dig deeper into it, but I like to think of Kubernetes as a new, let's say, operating system of a cloud. So what your operating system does a lot for you here, you're not even thinking about it. When you're opening a socket, you're not thinking where it is, you just know it's a socket 65,000 something. It is something that enables you this networking abstraction. And one more thing that we're missing, I don't know if it's mentioned, is the CRI runtime. So here we're saying Docker, but it supports any kind of CRI runtime, so it can be, we're using now in the backend Containerd, Rocket, whatever runtime you want to do. One very interesting thing, one very interesting project is called KubeVirt, I think, or something like that. It's an interface of a CRI runtime interface to virtual machines. So what it enables you to do is run virtual machines as these work units of Kubernetes. So if you're dealing with some legacy system that needs to go on Kubernetes but isn't working well with, let's say, Docker or containers, you can literally run virtual machines as a basic work unit, and things work great. We've been using them a lot in the backend of MSB in the previous versions, and it's working great. Basically what it is a way to run, let's say, containers or work units. In this case, it's Docker, but it can be a lot of other things. Are there any questions or something? Cool. So let's talk about Kubernetes objects. So as I keep saying, like when dealing with Kubernetes, usually when you start dealing with it, you will a lot of times, and it's a very natural progression, you will be thinking in terms of processes and things that you are used to doing before. I've been working obviously before Kubernetes was here, and I remember the IP tables and chef scripts and all of that. How you think in terms of Kubernetes is that everything is an object. Everything is an object represented by a YAML file. Everything is an object. Usually when you interact with it, it's a YAML or a JSON file. But what a Kubernetes YAML file is, if you're, let's say, writing one, it's a declaration of intent what you want to be run there. So you don't need to maybe understand this example completely, but every Kubernetes YAML file has 4 fields. API version and kind. So this is what identifies what kind of object are you running. So whether it's a service, an autoscaler, or something like that. So it's usually a combination of an API version and kind. In this version, in this situation, we are running a deployment in the apps v1 API version. So API version kind, metadata is also one of the 4 fields that always has to be there. So it's used to add names and labels and things like that, and annotations and things like that to Kubernetes. Name, so a combination of API version kind and name uniquely identifies an object. So in this case, it would be a deployment called MSB Web. Labels are literally labels. You can label anything you want. By itself, it doesn't have any semantic meaning, but they are, we'll see later, a very powerful mechanism to connect different parallel kinds in Kubernetes. And then the 4th field is a spec field. And this is unique to every kind of object. So in this case, I'll just go quickly through it, but I think it will make sense, but there's no need for you to try to remember stuff. So in this case, the spec field of a deployment, so it is one of these controllers that we've been saying that it requires, that it will ensure that there is a work unit running. In this case, it will run Nigel Poulton MSB hello Docker image, and it will ensure by the default there's always one version running. So if this Docker, if this work unit fails, it will establish a new one. A few other things that it allows you to do is if you're dealing with updates of your software, you can see here a strategy type rolling update, you can specify how quickly or how intensely should the rolling update be done if you're deploying a new version and things like that. So no need to remember all of that, but this is important that you know API version kind, metadata spec, the 4 fields that are always there, and spec is unique to the type of object that is there. Usually they make sense once you start thinking about it. So, I don't know if I've been using the word pod, I'm just used to it. I haven't introduced the concept of a pod, but we will do it now. So I've been saying you are running containers. Technically you are running containers, but Kubernetes doesn't think or work in containers. What it does is wrap the container or several container in a concept called a pod. It is a basic execution unit of a Kubernetes application, so it can be your Java service running, a Postgres instance running, something. So it is something that's wrapping around the one or more containers. The importance of it is it allows you to run several containers that are also isolated from all the other instances. So a purpose of this would be, maybe we can show it later. So every time you're deploying something, do not think of containers, think of pods, which are then running containers or VMs or however you set it up. So the 2 types of pods are obviously single container, so it's just a basic wrapper around the container, around something that's running. And then we have a more kind of advanced use case, but very useful when you are running multiple containers that need to work together. So the reason that it's set up this way is because they can communicate with each other through localhost, they can share volumes, and they can be treated as a unit of execution that's working together. It's a good practice to follow because of separation of concerns. So maybe this is a standard example that is always being used. So here we have 2 Docker, let's say, images running. One is a web server and one is something we call the file puller. So imagine that this file puller is some cron job or something that's periodically pulling for new content that needs to be displayed, and they are sharing a single volume. So if this is an Nginx server and it's sharing stuff from their standard I don't know, /share HTTP something, they are sharing a same volume. So this file puller could pull new content constantly and just put it in the Nginx's static folder, and this Nginx would immediately see it. So what an important thing to note is that if you have 2 of these pods running, they are completely isolated from each other. So these can talk together, these 2 containers to this volume. These 2 are running exact same software, but they have their own volume, their own thing. So unless you make an effort, they have a hard time communicating with each other. So the pod object itself, as I said, I think this might make sense to you much more than let's say, the deployment object. A standard API kind metadata spec, API version v1, basic version, kind pod. Metadata, we're going to name it Nginx. And you see now the spec, it's much different than the deployment one, and it's a very simple one. All it's saying is, this is a list of containers that I want to run. There is one container. Its name is Nginx. Its image is Nginx. And I want a port open 80. So if you were to run this, if you were to send it to a Kube API, to the Kube API server, you will declare your intent, and it will run an Nginx container wrapped in a pod. It's that simple. In this case, let's say a multi-container pod. Like when you see this, it sometimes looks scary, but after a while, you just get used to it and see that things really make sense. So in this case, we are running a pod with 2 containers. The 2 containers are the Nginx container and one container that's just gonna echo something to a volume. So this is the container level, right? And here you can see that on the pod level, we have declared a volume, named it shared data, and this is important. And now you see that this shared data is mounted in the two containers themselves. And this allows them to communicate. So if you were to run this container would echo hello from the Debian container into the Nginx's share folder, and it would be served. So obviously the details are not important, but you can see that the YAML itself has a structure to it, and a lot of this magic of binding volumes, creating them, managing all this communication is done basically by magic, and it kind of makes sense once you get used to it. So yeah, one important thing to talk about pods. I'm gonna ask for the last time, is there any questions? Otherwise, just interrupt me. Okay. While it is a basic work unit of Kubernetes, while everything is revolving around pods, you will rarely rarely do this. You will rarely say run this pod. Usually, what we do is use these controllers that we've been talking about to manage these pods. So here we say pods are ephemeral, but you know the saying, you should treat your servers in the cloud like cattle. So basically, this is what pods are. They do have their IPs, but you should not think about them. What you should declare to Kubernetes is, I want 5 of these pods running. And if it goes down, if Kubernetes needs to move them around, it will ensure that there are 5 pods running, but they themselves are not unique at all. If you create a pod and it crashes, it will not be restarted because there is no controller that's managing, that's looking whether it's there. And they are a basic work unit, but you will be using a lot of controllers to manage them. Okay, if we have pods, if you understand them now, now let's move to a new abstraction in Kubernetes called services. So it's a kind of, if you haven't dealt with Kubernetes, it usually is also, for me, it took me a while to get into the new language. If you're coming from a non-Kubernetes world, when you say service, you usually mean the actual process running somewhere, right? So all of you are, if you're developers, managing a service, a payment service or whatever. A good analogy to what you are saying in the old speak is the pods themselves, so the work units that are running themselves. What Kubernetes means by services is a networking abstraction, kind of like a socket, that allows you to communicate inside of Kubernetes. So a kind of complicated way to say it's an abstraction which defines a logical set of pods policy by which to access them. A simple way to maybe say it is, if you are running certain pods and you would like them to be accessed through a common name, you would create a service that's targeting these pods. We'll see later, if we create a service called HTTP, whatever you do inside of a Kubernetes cluster like curl HTTP, it would automatically be routed to the pods that it should be routing to. So they serve as a load balancing mechanism. I think it will become clearer much soon once we have an example. But basically what you do is, as we said, pods are cattle. They will die. They will be moving around. They will be getting new IPs. But the service abstraction, the service name, is a static thing that you will always be able to reference. It will know which pods are active, and it will route traffic to them. It will kind of randomly or kind of round-robin serve traffic to them. One important thing to note is, unless you're doing a lot of, let's say, effort, the traffic being routed to these pods is random. There is no simple way to define to which exact pod it should be running. So the pods should be created as stateless applications that are able to respond to any request that is coming to them. If you are expecting that from a certain user, the requests are coming to the same pod all the time because it's storing something in memory, it's doable in Kubernetes, it's just not a very good practice. So the motivation is obviously for if you're running, let's say, 3 Nginx servers and you have a peak and you would like to increase it to 50, you can do that easily through Kubernetes, scale them up, but you will still access them through this service abstraction, and it will just load balance traffic across all 50 pods. The 4 types of services that are available, just go through this quickly. The cluster IP service, yeah. What do you mean exactly by entry point? Mm-hmm. Mm-hmm. I will show you here. I'll show you. I'm just gonna go a bit forward now. So once you define a service, this is the key part of it. So you will tell her the service, the selector for this service is run my Nginx. And if you see these pods, they have this label, run my Nginx. So what actually happens in the background, and we have an example that will show this exactly, is there is a controller called an Endpoint Controller that's constantly managing all the running pods, and it's seeing the services that it's responsible for, so it will magically know where to route it to. We'll show it later in a bit, but let's just show you what services can do. Standard cluster IP service is, it will create a cluster-wide available IP to which you can point it to. Everything you send to this IP and to this port will be routed to one of their pods. A node port is a type of service that will open a port on every machine in your cluster. So every response, every request that goes to this specific port on anywhere on your cluster will be routed to these pods. And a load balancer is a very nice example of what Kubernetes does to you. We'll be creating one in the hands-on part. Basically what it does is exposes the service externally, so you get an actual publicly available IP. And it's just one of the examples of the magic that Kubernetes does to you if properly set up. So we are running on GKE, our backend, and we don't even think that it's a GKE cluster anymore. We just say we want a load balancer service, and it's set up in a way that it will contact Google Cloud's load balancer service. It will provision an IP and return it to us. So basically what it will do is hook up to an externally available IP, and all the traffic that's coming into it will be routed internally, right? And a type of service is an external name. If you want, accessing some API or something you have outside but want to use the service mechanism, you can. Everything that's coming to this services port will be routed to foo.example.com. Again, the service object, API version kind metadata spec, v1 service name my Nginx, and then this is the key part again. You can see it's different from the deployment from the port. I think it's fairly self-explanatory. You are telling, I want open port 80. If you don't specify the target port, it will be the same. And this selector is the key part. So coming back to where we were just a bit before. So I mentioned that these labels are a very powerful mechanism of connecting these disparate kind of parallel mechanisms in Kubernetes. So basically, what this service will do is route traffic to any pod that has this selector. So it can be more complicated. It can be tier, front end, environment, production, things like that. And then all of these are kind of ended, and all the pods that it's routing to have these labels. So these labels by themselves, they mean nothing. You can name them whatever you want, but they have a lot of meaning in binding these two different things together. So in this case, as I said, if you're running 3 of them, we'll see it later, it will route traffic to 3 pods, and if you scale them to 50, it will route traffic to the 50 of them. And you will just be using the service. And I'm trying not to cough. The final abstraction that we should be dealing with is the deployments abstraction. So this is one of these controllers, the control loops that we've been talking about. It's one of the controllers that's managing pods. Again, a technical explanation of it is it provides declarative updates for pods and replica sets. We will see once we go to the hands-on part, it will become much clearer. But as a controller, what you do is describe your desired state to the deployment, and then you can just basically, if they can, you can trust it that it will do its job properly. So maybe now it will make a bit more sense once we look at the deployment object. API version kind metadata spec is standard, so it's a kind deployment named Nginx deployment. So what we are telling it, we want 3 replicas running of something, and then let's just jump to this part. So if you notice this part, this is actually the same spec as the pod spec. So what we are telling now is run 5 pods that have this template. So it will run 3 replicas of a pod that has image Nginx running. But the key part, again, are these labels. So you tell it that its selector is a match labels type selector, app Nginx. So you see that these two are the same. So what this controller basically does is constantly ensuring that there are 3 pods running that have the label app Nginx, that have this template basically. So if one goes down, it will immediately schedule a new one. One cool thing that this deployment controller does to you are 3 things. One is the healing part of it. So if something goes down, they will start up. Another cool thing is the scaling. So you can even imperatively tell it, run a command, kubectl scale 50, and suddenly you will have 50 pods running. And the third cool thing that it does is allow you to upgrade your software in a nice gradual way. So what this means, if this was running Nginx 179 and you wanted to run 182, you would instruct it to this change, and it will gradually shut down the old ones based on the strategy that you define and create new ones. And then if you see something went wrong, you can roll back to an old version. So I hope you'll be able to see this, but this will try to tie it all together. So here, what we're trying to, let's say, is show you the different view that different controllers are having. I don't know if you can see it properly, but I'll try to narrate everything. So the state that we are currently in is we have 3 nodes running, node 1, node 2, node 3. We have the kube scheduler, which is the part that assigns unassigned pods to nodes. We have a deployments controller that the intent that it's received is that it wants 3 Nginx pods running. We have a service abstraction that has a target selector of app Nginx. And then I will just add this one more thing in there. It's something called an endpoint controller, what I talked to before. So what this controller does is just monitors for all the pods that are running and ensures that the services know to which pods stuff is being run to. I think it will become clear, but pause me if it's not. So this is the situation currently that's happening. There's nothing running in our cluster, and we have a deployments controller, the thing that ensures that there is enough pods running that says we need 3 Nginx pods running. So what it does is immediately it will, through the API server, create the 3 pods that they have to run. The kube scheduler will immediately, after that, see it that they have been unassigned. It will assign them to each separate nodes. The kubelets themselves then see, okay, I'm supposed to be running this. Software, our Nginx processes are running on the pods. As soon as this happens, so I'm using this example to show how Kubernetes is just this series of loops that constantly are going through the state. If something becomes unclear, please let me know. So suddenly we have our software running, but our service is still not routing traffic to them. As soon as they are running, the deployments controller will see that it has the 3 pods running. It is happy, and in parallel to this, the endpoints controller will see these 3 pods that are matching the label selector, the target selector of the label. They should be happening, and the service will start routing traffic to them. Is this somewhat clear to what's been happening now? Kinda. I think maybe through a failure scenario, we'll see how these parallel systems react to a change. So let's say this pod is going down. It's in a terminating state. Immediately, the deployments controller sees it and obviously is not happy with it. It schedules a new pod to be run. So the scheduler sees the new unassigned pod, assigns it to our node that it should be running. A pod is started on this node. The endpoints controller also notices that it's in a terminating state and should not be routed. Traffic shouldn't be routed to it. You'll notice that the service is not routing traffic to it. And as soon as it's running, both the endpoints controller and the deployments controller are notified of the change, and the traffic is reestablished to this new pod that's been running there, right? Could be, I don't know, could be a bit overwhelming to look at this, but once we start using it, I think it'll become much clearer. The important thing to notice here is that none of these things have sent like a message to each other, hey, these things have happened. All they did was observe the current state. So these windows are trying to show the representation, the window into the state that these controllers need. So it all happened organically. It's all just a lot of loops that are constantly looking at the current state. One other thing before we go to the, I think first the break, then the fun part. I don't know how I'm doing with time. The kubectl command is your main command how to interact with the system. It has a standard framework by which you tell it what you want. If you say kubectl get pods, that means get all pods. If you specify a pod specifically, you will get only one pod. If you say kubectl get pod nginx replication controller Postgres service frontend, so you always namespace kind of the object, and the name of the object. You will get these 3 objects, and what we will be doing a lot is this kubectl apply command. So basically what it does is takes a YAML file on your file system and posts it to the API server and tells run this thing. This is my intent that I would like to happen there. Okay, I think the break time is now, and then we can do the hands-on part. Yes?
Thanks. On your previous slide, you show a deployment controller. Can we go back? Yes, on the left left side. Is it what is a deployment controller? Is it replica set? What is it?
I've been trying not to use replica sets and all that. I think I will show it later, but I think it will just complicate things a bit. But technically, yeah, it's a controller has something called a replica set that then has pods. I think we'll show it later in more detail and the updates of what's happening. But here I just wanted to show this kind of their current view into the state of the system and the actions they will be doing based on it. Yeah, everything is always, yeah. There is no deployment controller. Okay, so no, this is not a Kubernetes object. This is an actual view of the controller into the state, right? No, these are endpoints objects that I've been trying to do. So I've been trying to show the view of these controllers into the system. So this is a controller, this is a controller, this is a controller, right? Okay, in the break, which is now, right?
Break. Drinks are ready at the bar, and then let's come back at 7:45.
If you want to follow along in the hands-on part, connect to Wi-Fi and download Chrome, please, and then it's all good.